So in this question, we have to express the given complex number 3 plus 2i divided by negative 2 plus I in its standard form. So let us begin by first writing down the given expression. So we have 3 plus 2i divided by negative 2 plus I. Now we're going to take the conjugate of the denominator, which is negative 2 minus I, and multiply it to both the numerator and the denominator. Now we'll try to find the product of the two complex numbers in the numerator first. So that would be 3 multiplied to negative 2 minus I plus 2I multiplied to negative 2 minus I. In the denominator, we have negative 2 plus I times negative 2 minus I, which is simply negative 2 squared minus of I squared. So using the identity, a squared minus b squared is equals to a minus b times a plus b. So let us further simplify. We get 3 times negative 2 is negative 6 minus 3i minus 4i minus 2i squared divided by negative 2 squared is 4 minus I squared. So we have negative 6, negative 3i, negative 4i will give us negative 7i plus 2, because I squared is negative 1. Similarly, in the denominator, we have 4 plus 1. Negative I squared will be positive 1. So negative 6 plus 2 gives us negative 4 minus 7i divided by 5. So this is the answer. So let's write it down in the standard form. So that would be negative 4 over 5 within brackets plus I times negative 7 over 5. So this is the given complex number in its simplified form. Let's do another one. So in this question, we have two complex numbers multiplied to each other. So after multiplication, the product must be expressed in its standard form. So let us begin by first multiplying the two complex numbers. So we have 1 multiplied to 1 plus 2i plus I multiplied to 1 plus 2i. So that gives us 1 plus 2i plus I plus 2i squared. So we have 1 plus thrice of I plus 2 times negative 1, since I squared is negative 1. So that gives us 1 minus 2 plus thrice of I, which is simply equals to negative 1 plus 3i. And then we have the given complex number in its standard form. Let's go to the next question. So in this question, we have to express the given complex number in its standard form. Now we have the complex number in a fractional form. That means we have in the form a over b plus c over d. Now when we have two fractions, they can be added by using the butterfly method. So what we do, we multiply the denominator, so that would be b times d. Then we take the diagonal element, so a times d is going to be ad, and then we multiply the elements in the other diagonal, which is b times c, and then we add it to the first one. So this is how we can add two fractions. Let's use it here. So we have 1 minus 2i multiplied to 2 minus I plus 3 plus I multiplied to 2 plus I divided by 2 plus I times 2 minus I. This will give us 1 times 2 minus I is 2 minus I minus 2i times 2 is 4i, and the negative 2i times negative I is simply 2i squared. Then we have 3 times 2 is 6, and 3 times I is 3i, I times 2 is 2i, plus I times I is I squared divided by, now the two complex numbers in the denominator are complex conjugate of each other, so and we apply the formula. A squared minus b squared is equals to a minus b times a plus b. So that gives us 2 squared minus I squared. So which gives us 2 minus I minus 4I. So plus 2I squared will be negative 2. We're replacing I squared by negative 1 plus 6 plus 3I plus 2I plus I squared, which is negative 1. So we have negative 1 divided by 2 squared is 4 and negative I squared will be positive 1. And let's finally add all the real parts. So the 2 and negative 2 will cancel out. Then we are left with 6 minus 1, which will be 5. Then we have negative I, negative 4y, that will be negative 5i. And we have positive 3i plus 12, which is positive 5i. So that will give us plus 0i divided by 5. This will finally give us 5 over 5 plus I times 0 over 5, or we can standard form, we can say it's simply I 1 plus I times 0. Let's go to the next question. In this question, we have to express the given complex number in this standard form. So let us begin by first adding the first two complex number. So we begin by using the butterfly method. So that is simply first multiplying the two denominators, which will be 1 minus 2i times 1 plus I. Then we multiply the diagonal, so 1 times 1 plus I will be simply 1 plus I. And then we add it to the product of the other numbers in the diagonal, that will be 3 times 1 minus 2i. So that should give us 1 plus I plus 3 minus 6i. And in the denominator we have 1 times 1 plus I, negative 2i, negative 2i squared, which should give us 1 plus 3 is 4. I minus 6i will give us 4i, 5i, divided by 1 minus I minus 2 times negative 1, which will be equals to, so that it finally gives us 4 minus 5i divided by 1 plus 2, which will be 3 minus I. So now it reduces to, our given expression reduces to 4 minus 5i divided by 3 minus I, whole multiplied to 3 plus 4i divided by 1 minus 4i. Now we multiply the numerator, so that would give us 4 times 3 plus 4i minus 5i multiplied to 3 plus 4i divided by, and we multiply the denominator, we have 3 multiplied to 1 minus 4i minus I multiplied to 1 minus 4i, which is equals to 4 times 3 is 12 plus 4 times 4i is 16i, minus 5 times 3i will be 15i, then minus 5i multiplied to 4i will be minus 20i squared divided by 3 times 1 is 3 minus 3 times 4i will be 12i minus I times 1 plus 4i squared. So this should give us 12 plus 20 plus 16i minus 15i divided by 3 minus 4, since I squared is negative 1, minus I 12 plus 1, which will be equals to 32 plus I divided by negative 1 minus 13i. So now we multiply the numerator and the denominator by the complex conjugate of the denominator, which will be -1 plus 13i divided by -1 minus 13i times -1 plus 13i. Then we perform the multiplication, so that should give us 32 times -1 plus 13i plus I times -1 plus 13i divided by -1 squared minus 13i squared, which will be equals to -32 plus 32 times 13 will be 416i, and we have plus y plus I multiplied to -1, that will be -i, plus I times 39 will be 39i squared divided by 1 plus 169. So we have finally -32 minus 13 plus 416 minus 1 whole multiplied by 1 divided by 117. So that should give us -45 plus 415 times I divided by 170, which gives us -45 over 170 plus I times 415 divided by 170, which when written in the simplified form will be -9 divided by 34 plus I 83 over 34. So this is the final answer. So we have 1 over 1 minus cos theta plus 2i sin theta when we have to express this complex number in its standard form. Well, let us begin by multiplying the numerator and denominator by the complex conjugate of the denominator, which will be 1 minus cosine theta minus 2i sin theta divided by 1 minus cosine theta plus 2i sin theta multiplied to 1 minus cosine theta minus 2i sin theta, and that will be equals to 1 minus cosine of theta minus 2i sin theta divided by 1 minus cosine of theta whole squared minus 2i sin theta whole squared. Now we have 1 minus cosine theta minus 2i sin theta. It will remain unchanged in the numerator. Then we expand it. So 1 minus cosine theta whole squared will be 1 minus 2 times cosine theta plus cos squared theta. So we have applied the identity a minus b whole squared minus 4i squared sine squared theta. And further simplification, we have 1 minus cosine theta minus 2i sin theta divided by 1 minus 2 cos theta plus cosine square theta. We have I squared is equals to -1, so this will become 4 sine square theta. Now, the final answer will be 1 minus cosine theta divided by 1 minus 2 cos theta plus cos square theta plus 4 sine square theta, because the denominator is now a real number. So we write it, this is sine square theta plus I times negative 2 theta, 2 sine theta, divided by 1 minus 2 cos theta plus cosine square theta plus 4 sine square theta. So this is the standard form of the given complex number. Now we can do a further simplification here. So instead of 4 sine square theta, we can rewrite it as 4 times 1 minus cosine square theta, because we know that sine square theta plus cos square theta is equals to 1. So which implies sine square theta is equals to 1 minus cosine of square theta. So if we look at the denominator, we have 1 minus 2 cos theta plus cosine square theta plus 4 times sine square theta, which we are going to replace by 1 minus cosine square theta. That gives us 1 minus 2 cos theta plus cos square theta plus 4 minus 4 times cosine square theta. So 4 added to 1 gives us 5 minus 2 cos theta, and plus cos square theta minus 4 cos square theta will give us negative 3 cosine square theta. So we can also change the denominator to 5 minus 2 cos theta minus 3 cos square theta.